It's the first video on series. First, we're looking at what the nth term of a series is. Now, a series is something that forms a pattern. For example, you might have 2, 4, 6, 8, etc. All right. And when a series, if a particular series follows a mathematical pattern, we can describe it by a formula. And the general term of a series will be labelled, it's written like this, capital T with a sub n. And this is called the nth term of the series, where n is the number of the term in the series. And when you've got this capital T sub n, n always starts from, well, it always has to be a positive integer. So we don't start with n is 0. You can't have the 0th term of the series. You could have the first term, the second term, etc., etc. So n must be a positive integer. Just a few quick examples here. If your general term, Tn, is given by 3n minus 2, find the first three terms of the series. So if we want to find T1, that's the first term. So the first term is T1, and we just replace the n with a 1, which is 3 times 1 minus 2, which is 1. The second term would be T2, which is 3 times 2 minus 2. That's 6 minus 2 is 4. The third term would be T3, which is 3 times 3 minus 2, which is 7. So therefore, they're the first three terms, and therefore, if I want to write what the series is, it's 1, 4, 7, etc. So that's what the series is, okay? Sorry, I just need to come back here. There is a slight difference between sequence and series. So they're the first three terms of the series. So the sequence is, that's just a set of numbers. It's 1, 4, 7. So actually up here, I'm going to put a sequence slash series, forms a pattern. That's the sequence there. And the series would be 2 plus 4 plus 6 plus 8 plus ... So the series is the sum of the terms in the sequence. So the sequence is 1, 4, 7, but the series is 1 plus 4 plus 7 plus etc. Okay, so just that slight difference there in terminology. For example, the nth term of a series is given by Tn equals 3n plus 4. Which term of the series is equal to 73? So we know that the nth term is 73, so we just solve 73 equals 3n plus 4. Therefore, 69 equals 3n, and so therefore n is 69 divided by 3, which is 23. The 23rd term is equal to 73. Just another few examples. Third example, the nth term of a series is given by Tn equals 2n minus 300. Find the value of n that gives the first positive term. So if this is going to be positive, then 2n minus 300 has to be greater than 0. Just solving that, 2n is greater than 300, so therefore n has to be greater than 150. So if we put n is 150, it's not going to be positive because n has to be greater than 150, therefore n equals 151. So the value of n that gives the first positive term in the series is 151. Or find the value of n for which the series Tn equals 400 minus 6n is less than 200. So we want Tn to be less than 200. This is what Tn is. So therefore 400 minus 6n has to be less than 200. So therefore, look, we can do this either way. We can put the 6n on this side, the 200 on that side, get rid of the negative. So we can go 400 minus 200. That is less than 6n. Here we're just adding and subtracting from both sides, therefore the inequality doesn't change, so therefore 200 is less than 6n. n is greater than 200 over 6, so n is greater than 33.3 recurring. So because n has to be greater than 33.3 recurring, therefore n equals 34. Now, if you want, you can check your answers when n is 34. So just checking when n is 34. For n is 34, you get that T34, that means that's the 34th term, is equal to 400 minus 6 times 34. Check. If you're ever not sure, putting n is 34 in, it gives us 196, which is less than 200. And if you weren't sure if it was n is 33 or 34, when you put n is 33 in, you get 400 minus 6 times 33, which will equal and that equals 202. So we can see that this is greater than 200, so that is not the answer. Okay, now the other way of looking at this, I'm sure you're fine, but I'll just go through it again, is if you decide to take the 400 over, you get negative 6n is less than 200 minus 400, which is negative 200. So negative 6n is less than negative 200. And then if you're going to divide both sides by negative 6, you have to flip the inequality sign around because you're dividing by a negative. So therefore n won't be less than negative 200 over 6. It will be greater than negative 200 over 6. So n will be greater than 33.3 recurring. Again, giving you the answer of n is 34. Example here, the nth term of a series is given by the formula Tn equals 2n minus 3. Which term of the series is equal to 509? So we've got Tn, so Tn is 2n to the power of minus 3 is equal to 509. That means 2 to the power of n equals 509 plus 3, which is 512. Now, to be able to solve this, we need to take logs of both sides. So we get, now you can either take log to the base n or log to the base 10. So log to the base e or log to the base 10 of both sides. So we could either go log to the base 10 of 2 to the power of n equals log to the base 10 of 512. And using the log laws, n log to the base 10 of 2 equals log to the base 10 of 512. So n equals log to the base 10 of 512 over log to the base 10 of 2, which is equal to 9. The other thing you can do is just take log to the base e or ln of both sides. And using the log law, we get log to the base e or ln 2 to the power of n is n ln 2 to the power of n equals ln 512. So n equals ln 512 over ln, sorry, there's no power of n here. So we've got n ln 2 equals ln 512. So therefore n is ln 512 over ln 2. And putting that on your calculator, you also get 9. Okay, now you wouldn't, look, if you did take log to the base 2 of both sides, and that would be another way of doing it, but then you have to do a change of base with your log laws. So the other way of doing it would be, I mean, I would do one of these. ln's probably the quickest one to write out, so I'd probably do this. But if you did do log to the base 2 of both sides, so we start off again with 2 to the power of n equals 512. So taking log to the base 2 of both sides, we get that. And log to the base 2 of, so we get n log to the base 2 of 2 equals log to the base 2 of 512. Now log to the base 2 of 2 is 1, so we get n is log to the base 2 of 512, but then we have to do a change of base here anyway, because you can't evaluate log to the base 2 of 12 on your calculator. And here you could either do ln of, you could do log to the base e or log to the base 10, for example, of each of those numbers and use the change of base, which is exactly what we have here, all right? Or you could take ln. You could do log, or from here, we could have log to the base e of 512 over log to the base e of 2. And both of those, of course, give 9. So you do end up with just that. So just take logs of both sides, either ln or log to the base 10. I wouldn't be taking log to the base 2 of both sides because you end up with the same, end up doing these same steps anyway.